All right, lesson 8.3 talks about something called vectors, and there are a lot of vocab terms in this lesson. So I really need you to go look at these page numbers, okay? There's a lot of terminology that I'm going to use in this lesson, and if you don't know what it means, it's going to be really hard to understand what we're talking about. Okay, so the first thing we're going to talk about is magnitude. So vector and magnitude are kind of important for you to make sure you understand what I'm talking about. And vectors are always kind of this like boldface letters. So make sure that you understand that that's why those are bolded, because we're talking about a vector. So the basic idea is that a magnitude is really just the distance. So if you remember distance formula, it's kind of that same idea right here. So if I have this vector, so let's say I've got, here's my initial point, here's my terminal point out here. So here's my vector. The magnitude is that distance from here to here. So that distance. Okay, so in this first one, they are wanting me to sketch the vectors on the coordinate plane, on a coordinate plane, and find the magnitude of each one of them. So I'm going to sketch them all on the same coordinate plane. You can do them separately if you have several problems that ask you to do that. So this first one is at -3, 2. So -3, 2 is literally right there, just like a coordinate point. Here's my initial point. This is my terminal point right here. So that's where it ends. So that one is A. B is going to be at 0, -2. So right here, again, here's my terminal point, or sorry, my initial point. This is my terminal point right there. That is B. And then C is at 4/5. So I'm going to say that's about 4/5 of the way. And then 3/5. So I'm going to go about right there. Again, there's my initial point, my terminal point. This is C. So that one's really tiny. I hope you can kind of tell what I'm doing there. Okay, then to find the magnitude, I'm just going to follow this situation right here. So I'm going to say this will be, so my magnitude is noted like that. And it is the square root of the first one squared plus the second one squared. Okay, so that's going to give me a square root of 9 plus 4, which is the square root of 13, which does not simplify, so I'm just going to leave that the way that it is. The next one, the magnitude of B, is the square root of 0 squared plus -2 squared. Okay, so that's going to be the square root of 0 plus 4, which is the square root of 4. That does simplify to just 2, so I'm going to simplify it down to that. The next one, the magnitude of C, is the square root of 4/5 squared plus 3/5 squared. Okay, so that's the square root of 16/25 plus 9/25. If I add those together, I actually get 25/25, which is really the square root of 1, which we know is just 1. Okay. One thing I would like for you to think about is, why do I not need the positive and negative here? So if I took the square root of 1, really that's +1 and -1. So I want you to ask yourself that question. Think through that and see if you can come up with an answer as to why we only need the positive here. All right, so example 2, I'm going to go through a whole lot of just kind of like definitions and rules just by going through examples of each. Okay, I feel like that's the easiest way to tackle it. So this first one, addition of vectors, you literally add those. So when we're talking about this would be my a sub 1 and my a sub 2, a sub 1, a sub 2. We're adding our a sub 1s and then adding our a sub 2s. So this first one, 3 plus 2 is 5. 4 plus -1 is 3. That's your answer. That's easy. The next one, scalar multiples. So if I've got 2 times this vector, that means I have 2 times the first one, which is 6, 2 times the second one, which is 8. Same thing if you're multiplying by a negative, you still just multiply. So negative 3 times 3 is negative 9. Negative 3 times negative 4 is positive 12. Done. Couple of definitions. When they say I have this bold-faced 0, that's a 0 vector. That would be 0, 0. That's just a definition you need to know. Same thing with this one. Negative a means I have negative a sub 1, comma a sub 2. So I could go ahead and say, well, really, that's like a negative 1 times those things. So that's really negative a sub 1, comma negative a sub 2. That's the same thing. Okay, so those are just definitions to know. Subtraction of vectors. You could think of it this way, where you say, I'm going to distribute through that minus sign right here, and then I'm going to add them. Or you could just say, I'm taking this minus this, and this minus this. So in this one, I've got a 3 minus a 2, that is 1. And then I have a 4 minus a negative 1, that's 5, because that's actually 4 plus 1. Now this one got a little more complicated. This one says, what if I have 2 times this minus 3 times this? So the first thing I would do is multiply. So this one would be 10 and negative 8 minus this one would be a, so I did not distribute through my negative. I'm going to leave that alone. I'm just going to take 3 times those things first. So 3 times negative 3 is negative 9. 3 times 2 is 6. Then I'm going to actually subtract those. Okay, so a 10 minus a negative 9, that would give me 19. And a negative 8 minus a 6, that gives me a negative 14. Okay. So then I've got another definition here of I and J, so vectors I and J. So this to me is kind of a confusing way to deal with these, but it really is true. This is the true statement here, so I really need to make sure that I show this to you. So 1, 0 is I, and 0, 1 is vector J. So what does it look like when I have something in I, J form of a vector? So that's what I'm going to show you now. So if I have this vector A, which I'm going to call A sub 1, A sub 2, that's how I'm going to write it. If I want that in IJ form, that means I've got A sub 1 I, which this should be like a bold I, plus A sub 2 bold J, vector J. So what does that mean in a situation like this? That means I have 5I plus 2J. Same thing with this one. I have 0I plus 2J. This one can actually simplify even more, because if I have 0I, that means it's not really there, it's 0. So this is really just can simplify down to 2J. Just simplify it a little bit more. So that's what those look like. So this right here and this right here, that's what that means. You could also go the opposite direction. If they gave you this and you wanted to work with it in this form, you could as well. So just know that those are kind of interchangeable. Something else to mention is that a unit vector, if they ever talk about a unit vector, you automatically know the magnitude is 1. Okay, so if I'm looking at something like this up here and they say this is a unit vector, that tells me that the length right here is 1. So that's important to note. Okay, so then let's look at example 3 here. They say if vector A equals 5 vector I plus vector J, so 5I plus J, and B equals 4I minus 7J, express this as a linear combination of I and J. That sounds so confusing to me. So I just started like breaking it down. So let me start with what they want me to express here and then start using what I know. So they want me to do this. I am not going to make those bold. I'm just going to write them as normal. But I know what A and B are. So I'm taking 3 times A and I'm taking 2 times B. So I'm going to write that out. This is really 3 times 5i plus j minus 2 times 4i minus 7j. So I just plugged in a and b. Then I'm going to go ahead and distribute. So this literally is just like your Algebra 1 stuff, okay? So that's 15i. This would be 3j, so plus 3j. Minus, right here, I have a 8i. And then I am going to go ahead and distribute this negative here. I'm going to make that a plus 14j. If you wanted to, you could distribute just the 2 and then go back and subtract, like we did with the numbers, but I feel like it's easier just to do it like that. And then combine things that look alike. So 15 minus 8 would give me 7 i's. And then, let's see, that's going to be positive. A 3j and a 14j is 17j. So that is a combination of a linear combination of I and j. All right, example 4. Find the magnitude of the vector A and the smallest positive angle theta from the positive x-axis to the vector, which they're calling OP. I'm not really worried too much about that, that corresponds to A. So again, sounds super complicated. I'm just going to start working this out though. The first thing they wanted me to do is find the magnitude of A. So I'm going to start with that simple part. The magnitude of A you can find by doing the square root of 3 squared plus negative 3 squared in this case. So that means I have the square root of 9 plus 9, which is the square root of 18, which you can simplify. That's really 3 square root of 2. So I would go ahead all the way down to that. Then the second thing they wanted was a direction for this one. So I'm going to call it a direction. So let's talk about what this looks like on my unit circle here. So if I'm looking at 3, negative 3, that means I'm over here 3 and then down 3. So I'm about right there. This is my vector, right? So I found that my magnitude was 3 square root of 2. And I want you to think about on a unit circle, where does that fall? This 3, 3 is very similar to something like a square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, sorry. So if you look at your unit circle, this really falls at 7 pi over 4, and that is its direction. Okay. So that's what they're asking for here. All right, example 5, again, sounds pretty confusing. So find a vector B in the opposite direction of this that has a magnitude of 6. So a couple of things I have to think about. I have to think about the direction of it. I have to think about the magnitude of it. So I'm going to start out by just finding the magnitude of this guy. So the magnitude of A is going to be the square root of 5 squared plus negative 12 squared, which is going to be the square root of 25 plus 144, which is going to be the square root of 169, which is really just 13. So that's kind of nice. But there's a formula in your book, and I'll let you guys go to your book, go in the lesson, and find this, where they start talking about U. So that's going to give me more information about this magnitude and finding things in the opposite direction, and sometimes it's in the same direction. Like, we have to think about all those things. So this is what they're giving me. And in class, I want you to ask questions about this, because, like, where does all this come from, right? I want you to start asking those types of questions. Maybe go into your book and look at where I'm looking at this, see if that makes sense. So don't just rely on these examples, go do some research. So in this case, I've got 1 over the magnitude of A, so that's 1 over 13, times A itself. Well, A was 5, negative 12. Okay, so that means I've got a 5 over 13 and a negative 12 over 13. Okay. From there, I know that vector B has a magnitude of 6. So that means if I want it to be in the opposite direction, that means I want the negative. That's going to switch directions for me. And then I want a magnitude of 6. That means I'm going to multiply it by 6. Okay, and I'm doing that to this new value that I just came up with. So my 5 over 13, sorry, and my negative 12 over 13. Okay, so that's going to give me negative 30 over 13 and positive 72 over 13. So that gives me the one that's in the opposite direction. Now, if I wanted it in the same direction with a magnitude of 6, I wouldn't have multiplied it by that negative. So there's going to be a lot in this lesson that, not a lot, there's going to be a few problems in this lesson that we did not necessarily do examples just like, that I want you to start asking questions about. So I'm trying to make you a little more independent in this lesson. I want you to go find some answers, and I want you to ask some questions, okay? So let me know what you need help with.